Hello students, in this class I am going to discuss about the Euler method to solve ordinary differential equation. So in this method actually the curve will be approximated by a sequence of straight line called as tangent. So we will have a curve in xy plane. So this is my x-axis, this is my y-axis. Okay, so if I have a curve like this, I will approximate this curve by a sequence of tangent, okay, and I will try to find the approximate value of the curve. That is the use of Euler method. Okay, so what we will do here is our aim is to solve dy by dx equal to f of xy with the initial condition with the initial condition in short form you can say IC as y of x0 equal to y0. So y of x0 is equal to y0. Whatever value will be here we will consider y0, and the corresponding value of y at that point will be y0. So for that what we will do is, for that let us take x, which will be x0, maybe x1, maybe x2, and so on, so such that the conjugated difference, the value difference between two conjugated values, that means x1 minus x0 is equal to x2 minus x1 is equal to, and so on, so xi minus xi minus 1 should be h. So this is the distance between two conjugative values. Okay, so we can write here, this means x1 minus x0 equal to h, and so x1 will be equal to x0 plus h, and similarly xi will be xi minus 1 plus I into h, where I may be 0, 1, 2, and so on. So if I put I equal to 1, I will get x0 plus h. If I put I equal to 2, I will get x2 equal to x0 plus 2h, and so on, so we will get the value. Now as I told you, the Euler method is nothing but approximation of a given curve by a sequence of tangent. So let us write the equation of tangent first. So we know the tangent at x0 y0. How can we find the tangent at x0 y0 is y minus y0 m into x minus x0. Equation of a line through a point. Okay, so m is a slope, where m is a slope. So this slope we write it as dy by dx. That slope we write as dy by dx. And so what the equation of the tangent can be written as y minus y0 is equal to dy by dx at the point x0 y0, because this is the tangent at x0 y0. So that's why I am writing dy by dx at 0 at x0 y0 into x minus x0 into x minus x0. But dy by dx is nothing but f of xy. So here this we can rewrite as y minus y0 dy by dx at x0 y0 means f of x0 y0 into x minus x0 into x minus x0. So here my aim is to solve dy by dx. So dy by dx is nothing but f of xy. And so that tangent I am replacing by f of xy. Now here depending upon the value of x, we can find the value of y. For example, from here we can write y equal to y0 plus x minus x0 into f of x0 y0 f of x0 y0. Now if I want to find y1, this is actually the approximation of the curve by a tangent at the point x0 y0. Now if I want to find y1, if I want to find y1, y1 is nothing but y value of y at x1. That means I want to find x1. So y means it is y of x. Y means it is y of x. So this x is nothing but here. Okay. So when I want to find y1 at the point x1, that means what I will write? Y1 should be y0 plus x1 minus x0 into f of x0 y0. So this we can again write as y0 x1 minus x0 is h, and here I will write f of x0 y0 f of x0 y0, and that will give you y1 equal to y0 plus h f of x0 y0. So this is the value of y at x equal to x1 at x equal to x1. Similarly, if I want to find the value at x y value of y at x equal to x2, similarly the value of y at x equal to x2 at x equal to x2 means I can write y of x2. That y of x2 we will denote it as y2 is equal to this that curve will be approximated by the tangent at x1 y1. So what I will do here is I will write y1 plus h f of x1 y1. Okay, and similarly y3 will be nothing but y2 whatever y1 y2 we are getting successively y2 plus h f of x2 y2 f of x2 y2, and similarly we will have yn plus 1 is equal to yn plus h f of xn yn. So this is called the Euler algorithm. This is called the Euler algorithm. So this thing is called Euler algorithm. If I put n equal to 1, n equal to 0, so here you can say n may be 0, 1, 2 and so on. So if I put n equal to 0, I will get y1. If I put n equal to 0, n equal to 1, I will get y2. If I put n equal to 2, I will get y3 and so on. So by using this algorithm, I can able to find the solution of the given differential equation with the initial condition y of x0 equal to y 0. So now what I want to do is, let me take an example here. Let me take an example here. Example is using Euler method, using Euler method, solve numerically, solve numerically the equation y dash equal to x plus y with the initial condition y of 0 is equal to 1 for x 0 and the common difference is 0.2 up to 1.0. What is the meaning of this one? I will tell you. So my aim is to solve the differential equation y dash equal to x plus y. Now just I will compare this one with the standard form. So y dash means dy by dx equal to f of xy, f of xy. So then my f of xy is nothing but x plus y. F of xy is nothing but x plus y. And now y of x0 is equal to y0. That means here x0 is 0 and y0 is nothing but y0 is nothing but 1. Now let me tell you what is the meaning of this one. Here my starting value is 0 and it will go up to 1 with the step size 0.2. So what are the values of h here is x is, I will start with 0 and then next value is 0.2 and then next value is 0.4 and then 0.6, then 0.8 and then 1. So what is the difference between these conjugative values? That will be my h. So this implies, so I will, this is my x0, this is my x1, this is my x2, this is my x3, and this is my x4, and this is my x5. So I want to find the y5 value. I want to find the y5 value at x5 is y5. And here what is my h? H is difference between two conjugative x values. So that is nothing but 0.2. That is nothing but 0.2. Now straightforward you can go for the Euler algorithm. So I want to find y at the point 0.2 and that is equivalent to saying y of x1 and y of x1 we can denote it as y1. Y of x1 we denote it as y1 because x0 is given. At x0 it is given. So using that value I want to calculate the value of y at x1. X0 means it is given here, initial condition. Okay, so y1, what is the formula of y1 here? Y1 is y0 h f of x0 y0. So this means y1 will be y0 is equal to 1 plus h is 0.2 into f of x0 y0 means x0 plus y0 because f of xy is nothing but x plus y. So f of x0 y0 will be x0 plus y0. And so if we simplify it, so what that will be nothing but 1 plus 0.2 into x0 is 0 and y0 is 1 and so it will be 1.2. It will be 1.2. So value of y1 is 1.2. Similarly you calculate y2. Y2 means value of y at x2 but x2 is nothing but 0.4. So y of the value at 0.4 and that is equal to, since y2 I am calculating, the algorithm says that y2 equal to y1 plus h f of x1 y1. Remember this thing. And so y1, we have y1 equal to 1.2. The successive value I have to apply. This one is y1. So 1.2, 0.2 into x1 plus y1, because f of x1, y1 will be f of xy is x1 plus y. So wherever x is there, we will write x1. Wherever y is there, we will write y1. And so finally, what will you get here is, what will you get is 1.2 plus 0.2. X1 is now, x1 is 0.2 plus y1 is 1.2. 1.2. So that means 1.2 plus 0.2 into 1.4. If you simplify it, you will get equal to y2 equal to 1.48. 1.48. Similarly, we can go for y3. Y3 means the value of y at x3. But x3 is nothing but the value of y at 0.6. And the formula says that when I am calculating y3, I will use the algorithm as y2 h f of x2 y2. And so that means y2 plus h into x2 plus y2. So y3 will be then, y3 will be then, y2 is the value what we have obtained just before that. So that is 1.48 plus h is 0.2 into x2. x2 is now 0.4 and y2 already got as 1.48. 1.48. And so this one will be 1.48 plus 0.2 into 1.88. So if you simplify it, you will get the value of y3 as, you will get the value of y3 as y3 equal to, y3 will be nothing but 1.856. And then go for y4. y4 means the value of y at x4. But x4 is nothing but the value of y at 0.8. Now since it is y4, so the algorithm is y3 plus h f of x3 y3, and that will be equal to y3 plus h f of x3 y3 means x3 plus y3. And now you put the values and you try to find the value of y4. y4 will be, y3 means the recent defined value 1.856 plus 0.2 into x3 means 0.6 plus y3 means 1.856. So if you simplify it, you will get it 2.3472. Okay. Now finally we want to get value of y5. y5 means the value of y at x5. Okay, so we need to find up to x5. We need to find it up to x5 because y value of y at 1 is equal to y of x5. So no need to go further after getting this one, and that is equivalent to saying y of 1. And according to the algorithm, Euler algorithm, we will have this one as y for h, f of x4, y4, and this is equivalent to y4 plus h, f of x4 y4 means x4 plus y4. And then if we simplify it, if we put the values, recent value of y4 is 2.3472 plus 0.2 into x4 is nothing but 0.8 and y4 is nothing but 2.3472. And if you simplify it, you will get the value of y5 as 2.9466. So here you stop your algorithm. Here you stop your algorithm. This is the value of the y at x equal to 1. So this is the algorithm of Euler to find the solution of ordinary differential equation. Thank you.